if your function is of 0 by 0 form or infinity by infinity form, then what will be the limit? Limit will be just derivative of that. When the derivative, let us see some example. Suppose you want to find log x upon x, and you would like to find limit, say limit extending to infinity, correct? First thing you should ask, is this satisfying Lapital rule? The condition for Lapital rule. Does this guy satisfy all the condition? What are the condition? If you put infinity on the numerator, it should go to infinity. If you put infinity on the denominator, it should go to infinity. So this is definitely satisfying. So it is of the form infinity by infinity. So what is the result? What is Lapital rule says? It says this limit extending to infinity log x upon x, it will be same as limit extending to infinity. Find the derivative of log x. What is derivative of log x? That is 1 upon x. And in the denominator, what is the derivative of x? That is 1. Can you solve this limit? Yes, 1 upon infinity. This is same as 1 upon n, or n goes to infinity. So 1 upon infinity, this goes to 0. As your x goes to infinity, 1 upon x is go to 0. So this is the answer. This is the limit. Correct? Okay. One more question. Limit, say extending to infinity, x raised to n upon e raised to x. What do you think about this? First of all, is this of the form infinity by infinity? Is this of the form infinity by infinity? Yes, of course. No, if you put x infinity on the numerator, it is x raised to n. So that is going to be infinity by infinity. Correct? And what is e raised to infinity? That is again infinity. Correct? So yes, this is satisfying. This is of the form infinity by infinity. So can I apply Lapital rule now? What is Lapital rule? Find the derivative of the numerator. So it will be limit n tending to infinity. What is derivative of numerator? What is derivative of x raised to n? That is n x raised to n minus 1, and divided by e raised to x will be as it is. Correct? If you observe it properly, I can still not solve this question. This is again infinity by infinity. So that means, can I apply Lapital rule once again? Yes, of course, I should do that. So if I am going to apply Lapital rule again, what will you get? You will get this is equal to limit n tending to infinity n into n minus 1 x raised to n minus 2 upon e raised to x. Do you see, again this is of the form where I can apply Lapital rule. Again, I didn't get any result. I am still stuck with that only. So what do you observe? In the numerator, after n times derivative, correct? What will you get? Suppose you are having x raised to 2. After 2 times derivative क्या आता है? What is first derivative? 2x. What is second derivative? 2. So if you are having x raised to n, after n derivative you will be getting n factorial, correct? So all the time, all the n derivative, that means I am going to apply my Lapital rule n times. So in the numerator it will be now limit n tending to infinity, it will be n factorial upon e raised to x. And again you see, in the numerator there is no term of x, and in the denominator it is so it is something like 1 upon infinity form. So this is 0. limit is 0. Yeah, is that clear? Yes. And one more thing you should remember actually, note limit extending to 0 plus, definitely I'm coming from plus side, f of 1 upon x, this is same as limit extending to infinity of f of x, which is quite obvious if you see. Here x was going to infinity and here 1 upon x goes to infinity. X goes to 0 plus, that means 1 upon x goes to infinity. In some cases we'll be using this actually. Yeah. And by using Lapital rule actually, you can do some more things. You can actually, whenever you are having something of the form 0 into infinity, correct, of this form, or 0 raised to infinity or infinity raised to 0 of this form, 0 raised to infinity or infinity raised to 0, that type of question also you can solve by using Lapital rule only. You know why? Suppose let us take an example of 0 into infinity form. Okay, and let us see how can you solve these type of questions. Say actually that is quite easy to do. 0 into infinity, that means what? 0 into infinity, if your function, if you are having two functions f and g, and f goes to 0 and g goes to infinity, correct, then what you should write? You should write f upon 1 upon g. Now as g goes to infinity, what about 1 by g? That goes to 0. So now you can apply, now this is of the form 0 by 0. So whenever your question is of the form this 0 into infinity or infinity into 0, you can make it either into 0 by 0 form, or you can also do that like this, g upon 1 upon f, correct? So g is infinity and 1 upon f. As f goes to 0, 1 upon f goes to infinity, as I just now told you. So this will be infinity by infinity form. You can do any of that case when you are having 0 into infinity or infinity into 0. And there are so many examples. What about the next one? What about this one? If you are having 0 raised to infinity form, that is you are having f raised to g, where f goes to 0 and g goes to infinity. How will you handle this type of question? Yes, how will you handle this type of question? When you are having, again, you'd like to make it of the 0 by 0 form or infinity by infinity form. That is the main motto for doing this, correct? So how will you handle? The best way to handle these people are take log. If you take log, what will happen? Just see, try to observe. If you say I'm putting y equal to f, say I'm putting y equal to f raised to g. Okay, if I take log here, so it will be log y equal to g times log f. And look at this thing actually. What is this? Your g goes to infinity. And what about your log f? As your f goes to 0, so this goes to 0. So this is of the form infinity raised infinity into 0. So how can you solve this type of problem when you are having infinity into 0? I just now told you. You just need to write g, log f upon 1 upon g. You just write it like this. Log f, this goes to 0 and this g goes to infinity, so 1 upon g goes to 0. So whenever you are having of the form 0 raised to infinity, just put y equal to that function and take log, then take the limit. At last you have to see, at last you will be getting the value of log y. You have to go back to your value of y. And how you can do that? You just put e raised to log y. And whatever your answer is from here, that will be e raised to that answer. So here that will be y equal to e raised to. That is the final answer. Yes. Similarly, can you handle when you are having infinity raised to 0? Can you handle that type of question? If you are having infinity raised to 0. Again, same thing, taking log, correct? If you take log, what will happen? Same thing, na? You will be getting 0 into infinity form. Again, can you solve that? 0 into infinity form. Yes, definitely. That is quite easy to handle. You will be just putting it as 0 by जो भी next function I am going to write it as 1 upon f. And that's it. Let us see some examples now. As we are doing so many types of questions, so it is better to do some example first. Find this. Limit extending to 1 x minus 1 into tan pi by 2. Tan pi x by 2. Think about this question and tell me how will you handle this. What do you see here? This is product of two functions, and what is the limit for the first guy? Here you can say limit extending to 1 x minus 1, that goes to 0. And what about the another guy? Limit extending to 1 tan of pi x upon 2. Pi x upon 2. That will go to tan pi by 2, that goes to infinity, correct? So you are having a problem of 0 into infinity form. What will you do? How will you handle this? Can you make it of 0 by 0 form? That is quite easy. See, limit extending to 1, you are having x minus 1 into tan pi x by 2. Can I write tan as 1 upon cot? So if I write limit extending to 1, I will be having x minus 1 upon cot pi by 2x. Can I do that? Yes. Now is this of the form 0 by 0 form? Do you see that? It is of the form 0 by 0. So can you handle this? Yes, you just have to differentiate numerator and differentiate denominator. That's it. That is easy. Okay. Let us take one more problem, say simple one. Limit extending to 0 x into log x. How will you handle this? And that is quite easy. X into log x. Maybe I'll just change it little bit. X into log of say tan x. Something like this. Yeah. How will you solve this? Yes, log of tan x. What happened when x tends to 0? What happens to tan x and what happened to log of tan x? when x goes to 0, what happens to log of 10x? Yeah, okay. I'll give this, think about it. If you're not answering, then I should say like this only. And send me the solution. At least there should be something, some thinking exercise for you. Now there is one more type of question. When you are having, say, infinity minus infinity form, then also you can handle this by using same your Lapital rule. When you are having infinity, that means you are having an f minus g, where f goes to infinity and g also goes to infinity. So now I would like to make this of the form either 0 by 0 or infinity by infinity. So the trick is this one, f minus g so what is f minus g? That will be equal to, if I make it say 1 upon g minus 1 upon f upon say f into g, what will this be? Try to see. What will this be now? Can I write it first of all? Can I write left hand side equal to right hand side, whether this is true? Yes, can I do that? Of course, because if you cross multiply, this is f minus g upon g by f, and here also f into g, so that will get cancelled. And now the question is, I wanted to make either of 0 by 0 form or infinity by infinity form. Am I through? As f goes to infinity, what about 1 upon f and 1 upon g? That means this numerator goes to 0. Do you agree? Yes? It should be 1 upon f into g. Then only it will get cancelled. It should be 1 upon f into g. Yes. And as f goes to infinity, g goes to infinity, what can you say about 1 upon f into g? That will go to 0 definitely, correct? Yes. So now do you see that I can write my negative f minus g in terms of this actually, 0 by 0 form. So I can handle this now using Lapital rule. Correct? Yeah. Yeah. So this was my function. I can observe that this is of the form c1 upon x. That means this is of the form infinity minus infinity. Correct? And what do I observe? This first term, that is f, and the second term, that is g. So can I write the whole expression in this form? So I'll be writing it as limit extending to 0, and this will be 1 upon g. 1 upon g. What is g? That is 1 upon sin x. So it will be sin x minus x. Correct? Am I correct? Yeah. This will be sin x and that will be x, and in the denominator it will be 1 upon, what is that? F into g. 1 upon f into g, that means what? This will become what? This will be on the numerator, no? That will be on the top, correct? That will be of the form x into sin x. And you just, after writing this, you just go through with this, whether both are same or not. Yes, if you separate them, you will get the same. I hope you agree. Correct? Now, what do you observe? Which form is this? Is this of 0 by 0 form now? Yes. Sin x minus x, this goes to 0. X into sin x, this goes to 0. So this is of the form 0 by 0 form. So I just have to take the derivative of that. What is derivative? Sin x का derivative is cos x minus 1, and in the here I am having limit extending to 0. Correct? And what is x into sin x? X will be as it is into cos x minus sin x will be as it is derivative of x, that is 1. What do you see? Do I still have any problem here? If you put x equal to 0, it will be cos 0 minus 1, that is giving me 0, and here I am having what? 0 to ye gaya, and sin x 0. So what do you see? I have to differentiate it again. This is again of the form 0 by 0, correct? This is again of the form 0 by 0. So you have to differentiate it again. Yeah? Or there is one more trick in this question you can use. Little bit of trigonometry if you are good with trigonometry. You see, what do you know about sin x upon x? When your limit extending to 0. What do you know about sin x upon x? If you go with trigonometry. This goes to 1. Do you agree? Basic trigonometry में किया था. Not trigonometry actually, definitely limit, 11th standard of limit. So you see here it is sin x, and you see this is cos x minus 1. Can I do something with this? Do you have any formula of cos in terms of that? Do you have any formula? No, it is not sin x. It should be sin square or something. See, cos 2x का formula क्या है? The first formula is cos square x minus sin square x, correct? And the second formula is 1 minus 2 sin square x. And the third formula is 2 cos square x minus 1. Which formula should I use? Which formula should I use here? I need what? I need cos x minus 1. So cos x minus 1 कहाँ से मिलेगा? See? From here I can get cos x minus 1. Look at this 2p. Why I am focusing on sin? Because I have this formula. Limit extending to 0 sin x upon x. I have this one. So I wanted to use this. That's why I am doing everything, whatever I can. I want to make everybody in terms of sin. So if you see, if I divide by x numerator and denominator, I'll be getting something. And that is easy to see now. X से divide करो, so here I will be having sin x upon x. Here I will be having x, and here this is whole upon x. So sin x upon x is what? 1. And here I am having x is cancelled. I am having cos x. And this is cos x minus 1. That is giving me sin square, no? So here I am having x, तो मुझे एक और x देना है इसको. Multiply and divide by x. So the final answer will be 0. Can you see it? If you don't see it, then just try to solve it by yourself. I hope you get. And similar to this, one more question. Limit extending to 0, say not 0, extending to 2, 1 upon x minus 2 minus 1 upon log of x minus 1. Again, try to solve this also. This is again infinity minus infinity form. How will you handle this? Again with the same thing, try to solve it. एक log का करते हैं. See, suppose limit extend. हाँ, log के लिए I have there are three types of question I can get. Either I can get 0 raised to 0, either I can get infinity raised to 0, or 0 raised to infinity, that is okay, or I can get 1 raised to infinity. There are three types of question where I should use log. Okay, let us see the first problem. Suppose the limit extending to 1, this is x raised to 1 upon 1 minus x. What do you see? Which form is this? What do you see? This is of the form 1 raised to infinity. Do you see? This is of the form 1 raised to infinity. So what you should do? You should first take the limit. Sorry, you should take the log. So इसको put करते हैं y equal to this. Take log y. You remember one thing: log and limit, they can exchange each other. So this will be what? Limit extending to 1 outside only. If you take log, it will be what? 1 upon 1 minus x into log x. What do you see now? Which form is this now? Yes, that means this is limit extending to 1 log x upon 1 minus x. What is this form? You see, this is 0 by 0 form. If it is 0 by 0 form, can I use my Lapital Rule? Yes, definitely. So this is limit extending to 1. What is the derivative of log x? Is 1 upon x. So I am having 1 upon x and minus 1. So I will be having minus 1 upon x. And the answer will be minus 1. But this is the value of log y. I'll write it here. Log y equal to minus 1. What else? Just e raised to log y लिख दो. And here e raised to minus 1. You know this. Here e and base is e. So this is what? Y. Y equal to e inverse. This is your final answer. Correct? So this is how you should handle this type of question. One more famous question on this is find the limit extending to 0 when you are having x raised to x. So again, what will you do? You'll put y equal to limit extending to 0. This is x raised to x. Take log y equal to limit extending to 0 x log x. Correct? What next? What do you see here? This is of the form, this was of the form 0 raised to 0, no? Now what do you see here? This is x log x. See, one more thing you should remember, when your x goes to 0, log x goes to infinity. I hope you know the graph of log x. If you see graph of log x, when your x goes to 0, your log x goes to infinity. And this gives you a hint of solving a problem which I told you to think. Maybe कहाँ पे गया वो? Yeah, log of 10x, again the same thing. This log of 10, this is also from 0 into infinity actually, which I already told you. I was doing 0 into infinity form in this here. 0 into infinity. So that's why I gave this problem. You try to see the graph of log x first and try to then analyze whether what you are doing. Okay? So what do you see? This is of the form 0 into infinity. So can I write it like this? That is limit extending to 0. Keep log x on the top, and can I write 1 upon x? Now this is of the form infinity by infinity as x goes to 0. You just differentiate and you'll get the answer. What is the derivative of log x? So this will be limit extending to 0. Derivative of log x 1 upon x, and what is derivative of 1 upon x? That is minus 1 upon x square. Correct? Cut हुआ क्या आएगा? You'll be getting minus x. So this is limit extending to 0 minus x. That is 0. Done. That's so easy. Correct? And in your practical, you will find some more problems. Try to solve this by using the technique. If you see something raised to something, then try to apply your logarithm and try to make it of the form 0 by 0 or infinity by infinity form. This is the only two things we are having. Any problem, if you are able to make it of 0 by 0 form or infinity by infinity form, then you can apply your Lapital rule. Okay? Yeah.